Welcome to this video on linear functions. We're going to look at how you can get from one aspect of a linear function as it's presented to you to another. We've seen linear functions in one of four ways. You've been given a table, all right, where you could get the table information and then you're asked to get the graph or rule from that table. Sometimes we'll give you a rule, also known as an equation, often in the form y equals mx plus b, but maybe you've been given it in other ways. Sometimes you've been given a graph and they ask you to get some points from that graph, put it on a table, or come up with a rule that represents that. And one of the most popular ones that they used in Chapter 3 was actually a pattern where they gave us a tile pattern so that you could visualize how is this pattern changing, how could we represent it mathematically, because the three ways to represent a tile pattern mathematically would be a rule, a table, and a graph. And that's what we're looking at here in this video. We're going to show you how to go from one of these to the other. Let's take a look at our first one. Taking a look at this one right here, we can see that they've given us a tile pattern. All right, and what we need to do first is we need to identify how many tiles are in each pattern and simply count them. Figure 2, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 tiles in Figure 2. Count them for Figure 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 tiles in Figure 3. And then you could count them for Figure 4, or you could also recognize that going from Figure 2 to Figure 3, we're actually doing a linear pattern here, and so we're just adding that same amount. All right, 9 plus 4 was that, so we should be adding 4 again, but let's just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We are indeed adding 4 in our pattern. And so what we want to do is we want to recognize that by adding 4 each time, that is our rate of change. We will also come to know our rate of change as our slope. And we will also know it as the letter m, because we will see a format of an equation called the slope-intercept form of an equation, and it's in y equals mx plus b form. And if you're worried about memorizing that, you don't have to. It's on your formula sheet. Here's our formula sheet for Algebra 1 Keystone exams, and you can see that the slope-intercept form of a line is right here. It also gives you a nice reminder of what the slope is. All right, now on here it shows y2 minus y1 over x2 minus x1. All right, but that just says it's our change in y. That's why they're subtracting to find that difference over our change in x. And again, that triangle is the symbol called delta, and it means change in. You'll see that in mathematics a lot. So that's what our slope is. In this case, we're talking about our slope as our rate of change, because we're looking at our tile pattern in particular, and we're seeing how it's changing from one to the other. So our rate of change is our slope. That's this value right here, and we just saw that that value is positive 4. In other words, we have y equals 4x. Now our b value is our y-intercept, all right, also known, I'm going to abbreviate as y-int, all right, also known as the number of tiles in Figure 0. It's the number of tiles in Figure 0. Now the thing is here, they only gave us Figure 2. So I'm actually going to use a table in order to go backwards and find out what it would have been in Figure 0. So to create my table, I'm just going to go x, y, all right, where x is my figure number, all right, and y represents my number of tiles. And I want to get back to 0, so I'm just going to fill out to where I have it. All right. Now I know Figure 2 was 9, I know Figure 3 was 13, and I know Figure 4 was 17. I'm merely inputting the number of tiles into my table. I'm just recording the data. And I'm going to work backwards by doing the opposite. Since I'm adding 4 in this pattern, I'm going to subtract 4 to go back. 9 minus 4 is 5. 5 minus 4 is 1. So how many tiles would there be in Figure 0? There would be 1 tile in Figure 0. That means that b is going to be a positive 1. So I'm going to have plus 1 as my rule. All right. Now that rule, you could plug that into your graphing calculator, and you could see a table and see that your table matches and everything, and you can even get a graph from that. I'm going to show you how to graph from the values that we have so far. First thing, I'm just going to plot what I have. Figure 2 was 9. So I'm going to put a point right at 9. Figure 3 was 13. that would be somewhere up here. It'd be off my graph, so I'm not going to bother plotting that. But I'm going to look to my table to see some of my other values. Figure 1 was 5. So I'm going to go to 1 on my x-axis and up to 5 on my y-axis. So 1, 5, and 0 was 1, so 0, 1. And that's enough information right there to get myself a line. I'm going to keep it in blue here. All right. So if I get myself a line that's going through this, it would look like that. All right. And I could draw that line, and we could extend this line all the way across my graph. All right. Now for me, it's a little bit harder to line that up because I can't use a ruler on here. But that's what it would look like. That's how you'd get your graph for this. Now a good line would actually have a nice little arrow at the other end down here because we're extending in both directions. All right. And that's how I go from my tile pattern to my rule, table, and graph. Let's take a look at when we're given the rule. In this case here, we are given the rule right off the bat. You can see they gave us the rule right up top here, y equals 2x plus 1. And you can simply substitute the values in your table in for x. Where did these values in the table come from? Well, they gave you this table, but if they don't give you a table, you pick the values. Draw yourself a table, and I always recommend picking -3 to 3. That's probably the best snapshot because you've got a couple on the left of 0, a couple on the right of 0, so some positives and negatives, and you get a good snapshot of where we're going. But just take this value, and we're just going to plug in 2 times -4 plus 1. Notice I replaced x with parentheses and substituted -4. That's our skill evaluating expressions as you saw in Chapter 2. Now, when I take that, I plug it into my calculator or I work it out by hand, and I find that y is going to be equal to -7, and I plug that into my table. All right. You can use your calculator to do this as well. Let's take a look at how we do that. If I'm using my calculator, I can come here and I can use the y equals button. And in that y equals, I'm going to get y1. And I can plug in the exact formula that they gave me, which was 2x plus 1. And I simply hit 2x plus 1. Make sure you use the x button over here, not the multiply. And once I do that, I can get a graph by clicking graph. All right. If the graph comes up a little funky and it's not the standard format of like 10 to -10, you can always go to zoom and select the option there. All right. The sixth option in that zoom memory is Z standard, which means it's a standard window or to give you a 10 to -10 zoom. And then also I can hit second and then graph again, and it will give me my table this time. And you can actually get your whole table where it will show you the entire table for that equation. Well, that's great because then you can get the entire table and you could fill it out here. As I look in my calculator after having done that, I see that it's -5, I see that it's -3, -1. Some of you might notice, hey, since it's a 2x, the rate is 2, which means it's going up by 2 every single time here. All right, and therefore I would go up by 2 again. I would get to 1, 3, 5, 7, 9. All right, and I can get all those values. I can take those and I can plot them straight on my graph from here as well. I'm going to assume that you know how to plot points, so I'm actually going to show you how we can use our rule to go straight from the rule to the graph, since in this problem we were given the rule to start with. Watch what I use. If I have y equals 2x plus 1, I start with this piece right here. I know that the b value, the constant in my equation, is my y-intercept, and I'm going to plot that. I'm going to start with a point at 1 on my y-axis. Then I also know that this is my slope, and I want my slope as a fraction because it's my change in y over my change in x. In this case, if it's 2, a whole number, I can put all whole numbers over 1. Now, how do I read this? Well, I read it as positive means up, negative means down, and I'll read it exactly as I see it. So being that it's a positive 2 over 1, I would read it as up 2 over 1. All right? So from my point, I would go up 2 over 1. We always go over to the right. Just like we read from left to right, we graph points from left to right. So I'm going to go up again. Up 2 over 1. Up 2 over 1. Up 2 over 1, and I can get all my points. If you want to go backwards, just reverse the process. Go down 2 and left 1. Make sure you reverse both directions so you still get a line. If you don't get a line, you did something wrong because we are talking about linear patterns. All right, so you should get a line. If you don't, you've got a problem. All right, and once you get all those, you can go ahead and you can connect them with a nice little line. Use your ruler to do so. We use rulers to make straight lines because all lines should be straight. All right, and I'm going to put my arrows at both sides. There it is. So that's how I go from my rule to my graph. Let's take a look at the next one. This is a silent board game. This is one that might be given to you at some point. And you can here see that they give you a table and they give you at least 3 values. You need at least 3 values because if you only have 2 points, you can get a line from 2 points, but you could also get other shapes on the graph. So to tell you that this is going to be a linear pattern, either they need to give you 3 points or they should tell you what is the line that connects these 2 points. We're looking at a linear pattern. So if you know it's a line, 2 points is enough, but if you don't know it's a line, you need at least 3 points. The most important point to give you is this one right here. If they don't give it to you, try and find that one first, because if you know 0, you can find out what you are adding or subtracting in a rule. Because remember, y equals mx plus b. b is going to be the y value when x equals 0. So in this case, right away, I know that y equals something times x minus 4. Because I know that when 0 is negative 4, the only way to get from 0 to negative 4 is to subtract 4. I can't multiply 0 by anything to get to negative 4 because anything times 0 is 0. All right, that's the multiplicative property of 0. All right, so in this case here, that's where I start. Now, I want to find out what is my slope, or what is my rate of change, or what am I increasing or decreasing by. And to do that, I'm going to pick any of the other points given to me, and I'm going to work backwards. I know that when I was given 2, I got 6. And I know the last step that I did to get there was what we just found, which was subtract 4. Which means if I go backwards and I do 6 plus 4, I get 10. So I need to ask, what times 2 gets me to 10? What do I need to multiply 2 by to get there? Well, I need to multiply by 5. All right, so that tells me my rule is 5x, and I'm going to test that in my other point. All right, just to test it, 5 times negative 6, the other one they gave me, minus 4. I'm going to plug it in for this point right here. And if I do that, I get 5 times negative 6 is negative 30 minus 4. Well, y equals negative 34. And therefore, I have my rule. I know my rule now, and I've got it. And I can use that to complete the rest of my table. And you can just keep plugging different values into your table. Go ahead and try and do that. All right, check your values in the table. See if you got the same thing that I did. All right, and now let's plot it on the graph. Again, I'm going to use my rule to go there. I like using the rule. It's a little bit quicker. You can just take the values out of the table and plug them into the graph. Use your ruler. I like to start with my rule. So I'm going to start right here. That is negative 4 for my y-intercept. So I'll come to negative 4 on my y-axis. And I'll use my slope. Once again, my slope here being 5. That means 5 over 1. Since it's positive 5 over 1, that means I go up 5 over 1. And I'll do it again. Up 5 over 1. Always going over to the right. All right, we read from left to right. We write from left to right. And if you want to go backwards to get another point, you can go down 5 and left 1. All right, make sure that when you connect them, use your ruler. Extend your line the full length of the graph. Put arrows on it. And then you've got your graph for you. Let me get my arrows on the bottom down here. Done. All right, and that's how we go from our table to our rule to our graph. Let's take a look at our last one. The final form that we're going to look at here is when you're given a graph and they want you to come up with a rule or they want you to come up with a table. And I just want to show out some points of this graph. This comes from one of your math notes box in the chapter. And when you look at a graph, there's a few things that I want you to pay particular attention to. The first thing is our y-intercept. Where is it crossing our y-axis? Because a reminder, here's our rule. It is the constant in our rule. It's the b value. So in this case, we know that the rule is going to have plus 4 at the end of it because it crosses the y-axis at positive 4. And then we also want to look at what's the decrease. All right, how are we going down? And in this case, from this point here to this point here, which I'm going to use since I don't have grid lines in between, I'm going down 4 over 2. All right, always from left to right so that the bottom is always positive. That means my slope is down 4 over 2. And negative 4 over 2 reduces to just negative 2. That's why it's negative 2 in my rule here. Y equals negative 2x plus 4. Now to get a table, you could again create your XY table. And you could go negative 3, negative 2, negative 1. And you could just generate the x values that you want going all the way across here. And you could plug any one of these values into our rule. All right, and so we plug in, let's just pick -3 for this first one. So then y equals -2 times -3 plus 4. And we see that -2 times -3 is a +6 plus 4 is going to give me 10. And I can plug that in. You can also use your graphing calculators I showed you before, so you can complete the rest of that rule as you go through it. It would be 8, 6, 4, 2, 0, -2. That would be the rest of that rule. I want to show you one more going from graph to rule, just so we get this. Let's take a look at this one on the right over here. Where am I starting on my y-axis? Again, I want 2 pieces. All right, where am I starting on my y-axis? -4, so I know my b value is going to be -4. What's my increase each time? Well, here I'm going up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And that reduces to just 1. That's my slope. This gives me 1x minus 4, or I could just simplify that as x minus 4. That's how I go from my graph to my rule. Come see me if you have any questions, and good luck.